All right, so thank you for coming. I think it was pretty long day for many of you. So thank you for stopping by. And let's check. This is a talk about Kafka on Kubernetes and stuff. So we're in the right room. I have 25 minutes, and I have a pretty interesting task to accomplish. I need to probably show you a few slides, deploy the Kafka cluster, deploy some of the apps that using Kafka, scale this cluster up, and see how the data is still all going, and we'll see some monitoring stuff. So a lot of things to cover within 25 minutes, right? Challenge accepted, right? Okay, my name is Viktor. If you're here already, you probably read my bio on the website. If not, you can find me on Twitter and ask any question about Kafka, Kubernetes, and streaming and stuff. So the also important thing, if you have a Twitter, you can tweet any slides that you like, because I have some funny slides that you might also tweet. You need to follow me. You need to follow Confluent, tweet with Percona Live, and after that you will get to join the raffle. And after that, I will find you and give you some prize. All right, good to go? Let's do it. So this is a talk where I like to talk about evolution of dev Kafka ops, of the people who's running Kafka in enterprises. So usually it starts with some basic shell scripts. People download Kafka from Apache. They run Zookeeper. They run Kafka. They have some configurations. They play around. They're doing the same on the multiple other machines. They're doing this, going. So this is where they start usually. Now, at some point, they realize that, yeah, there's lots of repetitive things that they're doing, so that's why they need to go for some automation. So Ansible, Chef, Puppet, all these things that allow you to provision the Kafka cluster or like provide your configuration storage, all things are good. Now, at some point, people start thinking about better utilization of resources, and virtualization was not the right choice, and they start looking to containers. They start thinking how to put the Kafka in the container, how to run this in the container, and the same problems with the brave new world with containers, like how to do logging, how to do monitoring, things like that. And after that, for that matter, they brought the Kubernetes to try to kind of solve all these problems, right? Kubernetes will orchestrate all these things for us and will be responsible for scheduling resources. We can just describe how we want to see the world, how we want to see our Kafka world, and Kubernetes will make it happen. Obviously, the Kubernetes also came from the Greek mythology. This is a god that makes you pay money for your cloud provider or whatever provider, maybe like internal provider, but it's like some funny money that some organizations use also for budget of running this Kubernetes internally. Now, quick question. How many of you folks running stateless, let's start with stateless workloads on Kubernetes? Who thinks it's a good idea? All right, so it's a good idea because you don't need to have a state. You just deploy your microservice app. It will be running, reading data from your database, because database is there for storing state. But what about stateful workload? Who's running stateful workloads on Kubernetes? Who thinks it's a good idea? It's kind of sort of, yeah. So because you need to figure out a lot of things. You need to figure out things about network. You need to figure out things about the storage. You need to figure out other things because there are so many moving parts in this picture that you need to fill in. You need to cover, and you need to know all about this. So why I have my talk called "Doesn't Have to Be the Hard Way"? So how many of you folks heard about the Kelsey Hightower? It's Kubernetes talk. I'm expecting. Everyone knows Kelsey Hightower. Who don't know who Kelsey Hightower is, you need to go today after the session, go to find a YouTube Kelsey Hightower playing Tetris on the stage of ChefConf. I think it was ChefConf. And after that, you will learn who's the Kelsey Hightower. How many of you folks heard about the Gwen Shapiro? All right, so few folks. So basically, Kelsey Hightower is the founding father and one of the main evangelists of Kubernetes from Google, and Gwen Shapiro. She's just an awesome person, and she did a lot of things from committing code to Kafka and being the product manager on some of the Confluent products, and also getting back to evangelism, writing books about Kafka. So they have something to, they know a lot of things about Kubernetes and Kafka, and a lot of things are seriously difficult. So things that the Kelsey mentioned is difficult is that Kubernetes provides you some basic building blocks that allow you to build your infrastructure, but to run the complex applications like Kafka, messaging system, like a database, anything that requires some tender love and care will require some additional knowledge. So that's why how you translate things from the bottom up of your evolution of Dev Kafka Ops, how you start with the easy life when you just do SSH, you start your shell scripts, going through automation. You need to translate this knowledge to brand new world of this private pass, basically. Kubernetes is your pass where you're running your stuff. And yeah, it is tricky. And you need to figure out a lot of things. You need to figure out how to get access to internal applications, external applications, how to manage your persistent volumes, because Kafka is a distributed system that requires storage. Plus, Kafka also depends on another distributed system called Zookeeper that also requires persistent storage. Now, imagine we have distributed systems, aka Kafka, that depends on another distributed system, aka Zookeeper, that runs on top of another distributed system, aka Kubernetes. So it's a lot of things can go wrong, right? Plus, as always, security is the last thing that we all have in mind. We're always forgetting about security, and it's intentionally that security here, but number 4, but not number 1, because usually people don't take about security seriously only at the point where there's some security breach, right? We don't want to be there. But again, point of this talk, deploy some Kafka here, right? To deploy this Kafka thing or deploy anything in Kubernetes, we do YAML, but we do like a fancy YAML called Helm charts. And I did a kind of explainer video where I was talking about how the Helm works, how it takes things from one place to another, and how it deploy workloads into Kubernetes. So you can grab this video from YouTube, but still, you can say, yeah, the stateful sets allow me to control order, how to start and stop the containers, how to do upgrades. However, it is not enough. It is not enough because in the complex systems that depends on distributed consensus, there's always some of the nodes. Not all nodes equally equal. So some of the nodes maybe have a little bit of knowledge. For example, in Kafka, there's a controller node that is responsible for taking care of the structure of the cluster or like a partition structure, all the kind of things. And you don't want to kill the controller just randomly, like based on the certain order, because Kubernetes doesn't know anything about this controller. So this is why you need to put some brains in your Kubernetes cluster in order to make it happen. Let's see how it works. So in this demo, I will deploy Kafka cluster in Kubernetes, and I will connect this app. I will show you this app is running, 2 apps talking to each other through Kafka, and after that, I will try to do scale up, increase the number of brokers, and see if application will still work. And yeah, let's do it. Let's see how it works. So I have this. I have this I have this Kubernetes cluster running in the Google Cloud Platform. I used this cluster a couple of weeks ago. I did a presentation at Kafka Summit London. And so when I need to deploy this, first thing, I need to deploy the operator. Operator is the brain that sits inside your cluster and responsible for serving requests to extended API. So I want to teach my kube control, which is standard tool for operating with Kafka and Kubernetes, to understand things not only like stateful sets or persistent volumes, but also do something like get Kafka. This is something that I want to teach kube control to show me. Now, in this case, I have this operator, and the way how it looks like here. 2 pods are running inside my Kubernetes cluster. They're ready, so meaning that they can serve all these requests. Now, the way how I want to describe my Kafka cluster is just something like this. So I don't want to think about storage, network, and all these things. I just want to deploy my Kafka. And basically, this is what I need to provide information to my admins, or information that I need to provide to my operator. In this case, I need to have Zookeeper, need to have Kafka, need to have a control center for monitoring and things like that. So before, let's do Zookeeper. So we deploy Zookeeper first. And also we can see how this Zookeeper thing looks like. So I mentioned this small thing called custom resource definition. And if I will do thing like, let me just do this, get Zookeeper. So in this case, I will have extension of the Kubernetes API that called the custom resource with name of Kubernetes, Zookeeper cluster. So in this case, Kubernetes understands that I'm actually running some resource that you can talk to standard Kubernetes API. And the cool thing about this, this custom resource can also report me status, what is going on there. In this particular case, it provisions right now in a couple minutes, a couple seconds, hopefully. Because we don't have a couple minutes, still pending. Still pending, still scaling up, but it's okay because this is how we work in Kubernetes. Some in the future and very quickly, the Kubernetes will make your request or make your state of the world as you want. So Kafka, let's deploy some Kafka then. Deploy Kafka. Okay, no, wrong one. So always be typing. Deploying component called Kafka, and we will deploy this kind of thing. So what is happening underneath? While deploying, I will explain what the things are happening. So this request goes into space. From the space, it goes to my Google Cloud, where I'm running my Kubernetes. And while this thing is doing it, it's not only starting ports, it's also creating stateful set. Stateful set is a special primitive inside Kubernetes that's responsible for or providing guarantee that you will have your pod will have a stateful network identity, meaning that certain network address, and will have a stateful disk identity. So in case of failure of this particular node, same the content of this persistent volume will be attached to the same pod, even maybe it would be on a different node. So in this particular case, what I see here, this is my pods that running inside the Kubernetes, and also for that matter, for Kafka, I can do things like Kafka here. So it's another extension of Kubernetes API that allows me to introduce Kafka cluster as a first level citizen inside your Kubernetes cluster. And in this particular case, all things that I care as an admin of Kafka, for example, how much JVM heap I will give, some of the information about metrics reporter. This is a special component that runs and will publish metadata into control center. All this stuff will be here. And also I can see the status. It is provisioning. So let's get back to our watch and see how our pods are up and running. Now it looks like we do things here, and the next thing that I want to do is to so deploying my app. My app is just simple Java application that sits inside my container, and this is how my deployment looks like. Just a simple deployment, nothing fancy, but only thing that is required this kind of configuration parameters. How I can get these configuration parameters? Again, remember, I already taught my kube control to understand how this Kafka thing works. And when my Kafka cluster is ready, it will expose this connection string. So in this case, all this configuration management happens inside your Kubernetes. So using the Kubernetes API, I can get this connection string and connect to my Kafka cluster. But in this particular case, I wanted to make this more explicit. So that's why I'm showing you how this information comes into my application. So I'll do create. So deploying my app. My app is up and running. So get me back to my pods. We'll see that we have this pod. So I'm doing very production-ready thing right now. I need to expose or somehow connect to my application through very useful port, or where is it? Port forwarding, very useful tool with the port forwarding. So in this particular case, I need my my key-lift application. In this particular case, I will be using this local port. Okay, all right. So my application will have a driver instance, will responsible for driving us to the places, and we'll have a rider thingy. So while we were playing in the background, I also deploy a control center, so we can see that our Kafka is okay. Now, as always, it's very fun to do live demos because the conference Wi-Fi is always cooperating and it's always stable, as we know, and we see this is what is actually happens right now. The Wi-Fi works amazingly, and we don't see we don't see particular map. No, that's okay. So in this case, I probably will be able to show you something else. Now, while it's loading, I still have some time to go through some slides. This is supposed to be your reaction, but you know, because of the conference Wi-Fi is cooperating so much, it's not that. Another important thing that I mentioned, security, is also a very interesting topic. So essentially, the Kafka has a couple capabilities that people usually take into account when they configure security. So first of all is the data in motion, meaning that how you would encrypt the traffic between your client application and your broker application, especially if you're running this in the public cloud and exposing this broker to outside world, you need to at least provide a SSL access. So operator provides the configuration out of the box. If you don't configure anything, we enforce at least the username and password, even though if you're running this on top of the plain text, but it's kind of still binary protocol. It's called plain text, but there's no encryption on the wire. But we also can do SASL plain and TLS notification. We can do provision of the trust stores and key stores through the Kubernetes secrets, and we automating this configuration in order to all these components will be able to connect. So once you remember that connection string that I show you, this connection string actually has all security configuration that will be available to the client to connect to secure Kafka cluster. All right, so monitoring. So monitoring is also a very important aspect because not only you're running a distributed system depends on another distributed system, but also you're running this distributed system on top of, okay, so in this case, my pod is up. Now I need to do another very enterprise-ready command. So I will port forward from my Google Cloud to my local port and admin. Okay, cool. I hate Google Chrome so much because it doesn't work with my awesome shortcuts. While I was talking, it's actually my app is up and running here, and now I can show you how it actually works before I go into scaling things. So basically, as you can see, my driver's over here. And also, as you notice, it read my coordinates, so it basically starts where we are. So, and my rider, now you can see my rider, I clicked on the screen of rider and appeared on the screen of driver. So the way how these two microservices communicate to each other, they use Kafka topics. And if I go to my monitoring system and I will see these topics that the driver would put information about driving into this topic and the rider would put information about this topic. So let's see if we will have something. Now my driver can go and pick up this, this little guy. Just click here and now the screens would be synchronized through Kafka topic. As you can see, these two cars are moving to each other, and in a few seconds, it's going through space, coming from space. We should be able to see some information that goes into this topic. Let me see if a rider would be more responsive. Maybe something is not working correctly. Now let's try to scale this thing up. So now I have a four 4 brokers, as my monitoring system shows me 3 brokers running. I want to scale this up to the point where I have 4 brokers. Usually you don't do this in production. You're not going to Kubernetes cluster. You're not editing things. You're going through the change management, change control, and capturing these resources. Helm supports different releases. You can have a different version of the release, but screw that, YOLO. All right. So let's see if it actually does something. So we should be able to see that the container will be created, though. So this is how it works. We defined a custom resource. We just modified custom resource, and our operator noticed that we modified this custom resource, and now it will make this thing happen. And what is actually will happen underneath? It's a really exciting thing, but unfortunately I cannot show you on the screen how it's going, because the internal brain is actually already taking care of this distribution, and it checks like, okay, so there was some configuration change that I need to do, and if this configuration change require me to restart this broker, or it's a configuration that doesn't require this, I can do dynamic change. So in this case, it updates configuration onto other brokers. Also, when we need to restart some of the brokers, in some cases, we need to figure out that one of these broker will be controller. So we want to postpone the restart of this broker because controller will have some important information that will require some time to repopulate. Another thing is that we, in order to not lose the data during this the process of upgrade, we need to wait until our, I love that shirt. We need to wait until our the partitions will catch up. So we will see this in the monitoring thing. There's a parameter called under-replicated partitions. So in this particular case, there are no under-replicated partitions in this case. But if in case of something will happen, this is one of the most important metric that allows you to see like if your application is actually works or not. And this is this procedure that operator handles. Because this is something that is programmatical, it's difficult to define this in the standard YAML file. So this is why it requires some logic that runs inside Kubernetes. So if you're interested in more complex, deployment and multi-Kubernetes cluster Kafka replication between 2 public clouds, I actually did this also on the stage in New York at the Kafka Summit, and the video is available. You can also go there and watch that, how we providing external access, how we provision the DNS names, how we dealing with all this stuff, and we're getting fully ready to use application, fully ready to use Kafka broker that's available to you. So the cool thing about this, we also didn't work on this in vacuum, even though Operator and Kubernetes powers Confluent Cloud, which is the best Kafka managed service in the world. They didn't pay me to say this. I use this all the time myself, like for everything. Just go there and confluent.cloud. We use the knowledge of some of the customers who run the Kubernetes in production workloads. So this is why I started with this quick survey. Who thinks we also started with our customers same way. Who thinks it's a good idea, and not many people show up. Now people work with us and make this thing working. And now everyone thinks it's a good idea. Now, thank you so much for your time. Thank you so much for finding this moment to stop by and listen to my presentation. If you have any questions about Kafka, Kubernetes, we have a Slack community. I'm usually hanging out in this Kubernetes group. If you have any questions, you can always find me on Twitter. This is where I always hang out. And let's see if we were able to. No, you see, something is actually wrong. And we see number of under-replicated partitions going up. So something is terrible is happening. So what is actually happening? It's a rolling restart. So now operator goes in restarting each individual node to make sure that the cluster configuration that I changed is actually will be applicable. So probably I still running previous version of the operator because this something is not supposed to happen. But hey, I think this is winning, right? I think this is good. For 25 minutes, you have a running Kafka cluster. You have let me see if application is also running. I'm pretty sure it is, but just to make sure. And you see, our driver arrived to our rider over here. You see? How cool is that? I think it will deserve some of the round of applause. And thank you so much for stopping by. I will be available for advanced interrogation if you have any questions right after the talk, because I need to pass the microphone to another speaker. Thank you so much.